Let's look at Newton-Raphson method, also generally known as Newton's method. Okay, let's look at the first problem. F of x is equal to x cube minus 7x square plus 8x minus 3. What we have to do is figure out its zeros. That is, we have to figure out where exactly this curve crosses the x-axis. Okay, so how do we figure this out? We are given that the zeros is somewhere near 5, that is x not equal to 5. So this is our guess. Either it has been given to us or we have to guess this. Okay, now based on this we are going to figure out the much better approximation of what the zeros are going to be. Now the first thing that we have to do is differentiate this. So we get 3x square minus 14x plus 8. Okay, and this is where the fun starts. Our much better approximation, that is x1, is going to be x naught, our initial guess, minus f of x naught divided by f prime of x naught. If we do the substitutions, what do we get? 5 minus, now if you evaluate f of x naught, what we get is, okay, let me actually write it, by f prime of 5. Okay, so this becomes 5 minus f of 5. So we substitute this 5 in f of x and we evaluate. What we get is minus 13 divided by, now we substitute f5 in the f prime of x, we get 13. This would be 5 plus 13 by 13, 1, which is equal to 6. So this is our approximation when we go through our first iteration of the Newton's method. Now let's see whether we can better this. So we apply this rule once more. So our second approximation is going to be, this becomes our x. Instead of x naught, we will put x1 minus f of x1 by f prime of x1. So here it was x naught. We were using our initial guess and evaluating it. Now we are going to use the second guess or second evaluated approximation. Okay, so this will become 6 minus f of 6 by f prime of 6. If we evaluate it, we get 6 minus 9 by 32, which is equal to 192 minus 9 by 32, which will be equal to 183 by 30. And if we do this again, so now what will it be? It will be x2 minus f of x2 by f prime of x2. This will give us 5.6862019. And if we take one more iteration, this will be x3 minus x of x3 by f prime of x3. This would give us 5.6857795. And if you do the substitution using the calculator into the original equation, original expression, you will get 0. Not exactly 0, but 0.0000, some numbers will come. So it is quite a close approximation. Okay, so let's look at the second one. F of x is equal to sine x plus x cube plus 2, and the initial guess is given as minus 0.8. Okay, let's very quickly figure out the derivative. We get sine x is cos x plus 3x square. Okay, now x1 is equal to x naught minus f of x naught by f prime of x naught. Now that you have seen what we have to do, I'll just directly write the result. Minus 1.094590. Okay, now x2 will be x1 minus f of x1 by f prime of x1. This would give us minus 1.045186. And similarly, if we go through this again, we will get x3 equal to minus 1.04338883, and x4 will give us minus 1.04338859. So if you notice, it is getting closer and closer. And now when do we stop? Theoretically, we can keep going, but when do we stop? Let's say we have been asked to figure out the zeros up to 4 decimal places. So up to 4 decimal places, here actually up to 5 decimal places, we have the same digits. So we can stop. Okay, so this is our zeros of the function. Okay, let's look at the third one. Third one is f of x is equal to minus x to the power of 5 plus 4x cube minus 4x minus 2, and x naught is given as minus 1.6. F prime of x is equal to minus 5x to the power of 4 plus 12x square minus 4. x1 would be x naught minus f of x naught by f prime of x naught, which would give us, if we do the evaluation, we will get minus 1.8477. Second time when we do this, we get x1 minus f of x1 by f prime of x1, which gives us minus 1.7682. So this is the zeros of this function. Okay. Fourth one, f of x is equal to cos 2x minus 2x, and x naught is given as 0.6. So f prime of x is equal to, cos is minus, so minus sine 2x times 2 minus 2. This can be simplified as minus times minus, no, minus minus. So this will be minus 2 sine 2x minus 2. There is no multiplication here. There is subtraction. Okay. So now x1 is going to be x naught minus f of x naught by f prime of x naught. And if we evaluate it by substituting 0.6, we get 0.38322, and x2 would be x1 minus f of x1 by f prime of x1, which would give us 0.36962. So this would be the zeros. Okay. Now, fifth one, f of x is equal to sine x minus x cube plus 1, and x naught is equal to 1.4. See, the initial guess, the closer it is to the actual zeros, the better will be our approximation. Okay, so f prime of x is equal to sin x is cos x minus 3x square. X1 is equal to x naught minus f of x naught by f prime of x naught. Evaluate it, we get 1.26715. X2 is equal to, second iteration will give us x1 minus f of x1 by f prime of x1, which gives us 1.24936. So this is the zeros of this. If you want more accurate numbers, you'll have to keep repeating this till sufficient number of decimal digits are starting to repeat. Okay. Now sixth one, f of x is equal to cos x plus x cube minus 2 and x naught is equal to 0.9. Okay, f prime of x is going to be minus sine x plus 3x square. X1 is going to be x naught plus f of x naught by f prime of x naught. Evaluate this, we get 1.29436. And second iteration will give us f of x1 by f prime of x1. This will give us 1.18574. So this is the zeros of this. Let's look at the seventh one. Now here, let's change it up a bit. We are given y is equal to x cube plus 4x square plus 4x plus 3. There is one curve. And we are given another curve, minus x cube plus 4x square minus 5. And now here we have to figure out the point at which these two intersect each other. Okay. And the initial guess is given as minus 1.4. So remember, these are two curves. We have to figure out where exactly it intersects. Okay. So if it is going to intersect that particular point, whatever be the value of x, if we substitute it to both these two equations, they will be equal, right? At the point of intersection. So which means x cube plus 4x square plus 4x plus 3 is going to be equal to minus x cube plus 4x square minus 5. And this will be true only where they intersect. Okay, let's simplify this. Minus x cube comes this side, so we get 2x cube. 4x square and 4x square cancels out. Then we get plus 4x plus minus 5 comes this side, so it becomes plus 5. 3 plus 5 is 8, equal to 0. So again we have to figure out the zeros of this equation. For what values of x will it be 0? Now we can simplify it further by taking 2 common out. We get x cube plus 2x plus 4 is equal to 0, which means we can cancel out 2. We get x cube plus 2x plus 4 equal to 0. So we have to figure out the zeros of this. Okay. F prime of x. So let's say this is f of x equal to. Okay. So f prime of x is going to be equal to 3x square plus 2. And our x naught is minus 1.4. Yes. So x1 will be x naught minus f of x naught by f prime of x naught. If we do the substitutions and evaluate it, we get minus 1.20406. Okay, let's do one more iteration. X1 minus f of x1 by f prime of x1. Evaluate it, we get 1.1 7985. So this is the result. So if you substitute this into both these two, you will get the same result, showing that they intersect each other at that point. Okay. So eighth one, y is equal to sine x and y is equal to minus x cube minus 2, and the initial guess is minus 1.2. And here again we have to figure out the value of x where they both intersect each other. Okay. So again, if they intersect each other, these two are going to be equal. So sin x is equal to minus x cube minus 2, which implies sin x plus x cube plus 2 equal to 0. Now let's say this is f of x. Okay. So f prime of x is going to be cos x plus 3x square. Yes. Okay. Now x naught is, remember, minus 1.2. So x1 is going to be x naught minus f of x naught by f prime of x naught, which gives us minus 1.059037. Now x2 is equal to x1 minus f of x1 by f prime of x1, which will give us minus 1.04355 Okay, so this would be the result. Okay, ninth one, y is equal to x to the power of 5 minus 3x cube, y is equal to minus x cube plus 2x square plus 1, and x naught is given as 2. Again we have to figure out the value of x for which these two are equal, or in other words they intersect each other. So x to the power of 5 minus 3x cube is equal to minus x cube plus 2x square plus 1, which implies x to the power of 5, x cube comes this side plus, so minus 3 plus 1 gives us minus 2x cube minus 2x square minus 1 equal to 0. And let's make this as f of, so f prime of x is going to be 5x to the power of 4 minus 6x square minus 4x. Remember, x naught equal to 2. So x1 is equal to x naught minus f of x naught by f prime of x naught. Evaluate this, we get 1.8542, and x2 will be x1 minus f of x1 by f prime of x1, which gives us 1.8126. 10th one, y is equal to minus x to the power of 5 plus 2x cube minus 1, and y is equal to x cube minus 2x square plus 3, and x naught is given as minus 1.5. Okay, point of intersection, they both will be equal, so minus x to the power of 5 plus 2x cube minus 1 is equal to x cube minus 2x square plus 3, which gives us minus x to the power of 5, 2x cube minus x cube, so that will be plus x cube plus 2x square minus 1 minus 3 minus 4 equal to 0. So let's take this as f of x. Okay, now x naught is minus 1.5, so x1 will be x naught minus f of x naught by f prime of x naught. Evaluated, we get minus 1.30788 h. Okay, second approximation would be, or rather third, initially it was just a wild guess. This would be a much better approximation and this will be much more. So x1 minus f of x1 by f prime of x1, which gives us minus 1.23926. Okay. And if we go further, one more iteration, we get x2 minus f of x2 by f prime of x, which would be minus 1.231748. So this would be the value of x for which where the intersection will happen. Okay, 11th one. Let's do a very funny kind of thing. Y is equal to sin x and y is equal to cos x. So for what value of x will sin x and cos x be equal? Or in other words, where will these two curves intersect each other? And let us say x naught equal to pi by 6, our guess. Okay. Now, again, if they are intersecting, these two are going to be equal. So that means this can be written as sin x minus cos x equal to 0. Okay. So let this be the f of x. So f prime of x is going to be cos x minus sin x. So plus sin x will be the derivative of this function. And x naught is equal to pi by 6. So x1 is equal to x naught minus f of x naught by f prime of x naught. This will give us 0.7915. x2, x1 minus f of x1 by f prime of x1. This would give us 0.79154. First four digits are already same. So we can stop here. So this will be our answer. Okay. Now again, let's change gears. Let's say we have been asked to figure out the fourth root of 6. And we have been given an initial guess of 1.5. Okay, first of all, let's convert it into a function. Let's say x equal to fourth root of 6. Take it to the power of 4 on both the sides. We get x to the power of 4 is equal to 6. Fourth root and fourth power cancel out each other. And this can be written as x to the power of 4 minus 6 equal to 0. So this becomes the function. So which means f prime of x is going to be 4x cubed. Okay. Now that we have this, let's figure out a better approximation. So x naught minus f of x naught by f prime of x naught. So this will be 1.5694. Let's do it once more. x2, x1 minus f of x1 by f prime of x1, which gives us 1.5651. And if you take this 5651 to the power of 4, this will give you 6.000278. So up to 3 decimal places it is correct. Okay. So now let's look at 13th one. We have to figure out the cube root of 5. So again, let's say x equal to cube root of 5. Cube both the sides. We get x cube is equal to 5. X cube minus 5 equal to 0. So this becomes the function, and f prime of x is equal to 3x square. Now, suppose we have to guess x naught. The initial guess we have to. Then how do you do that? 1 times 1 times 1 is 1. 2 times 2 times 2 times is 8. 2 cube is 8. So It is closer to it, right? Uh, 5 minus 1 is 4, 8 minus 5 is 3. So it is closer to 8. Uh, so it must lie somewhere in between 1.1 and 2. Let's keep it as 1.5. See, the idea is to give you as to how to figure out a guess, initial guess. Okay, so x1 is equal to x naught minus f of x naught by f prime of x naught. This will come to 1.7407. Second iteration, we get x1 minus f of x1 by f prime of x1, which gives us 1.7105. So this will be the cube root of phi. So 1.7105 to the power of 3 will be 5.0046, which is again quite a good approximation. If 14, let's look at square root of 5. So x equal to square root of 5, x square is equal to 5, x square minus 5 equal to 0. So this becomes our function, and f prime of x is equal to 2x. Okay. Now x naught will be what? Again, we have to make the guess. So square root of 1 is 1, square root 2 is 4, square root of 3 is 9. So it is slightly above 2. So let's take it as 2.25. You can take 2.1, you can take 2.2. I have taken 2.25. Now let's improve this approximation. x1 is equal to x naught minus f of x naught by f prime of x naught. This will give you 2.4166. Again, x2, second iteration, x1 minus f of x1 by f prime of x1. This will give us 2.2428. Actual square root of 5 is equal to 2.23606. Right? So pretty close. If you want it much more closer, take it to x3, x4. Okay. Now 15th one, cube root of 4. So again, x equal to cube root of 4, x cube is equal to 4, x cube minus 4 equal to 0. So this will be our f of x, which means f prime of x is going to be 3x square. Now what will be x naught? 1 times 1 times 1 is 1, 2 times 2 times 2 is 8. So again it is between 1 and 2, but it is closer to 1 than to 2. So let's take it as 1.4. Okay, x1 is equal to x naught minus f of x naught by f prime of x naught. This gives us 1.5926. x2 is equal to x1 minus f of x1 by f prime of x1, which gives us 1.5874. And this would be the, you want more precise answer? Do some more iteration. Okay, 16th one, cube root of 2. So again, x cube equal to 2. That means x cube minus 2 equal to 0. So this becomes our function, and f prime of x will be 3x square. Okay, x naught will be what? 1 times 1 times 1 is 1, 2 times 2 times 2 is 8. So it is much closer to 1. So let's take it as 1.2. So a better approximation would be x naught minus f of x naught by f prime of x naught. which is equal to 1.29629. A much better approximation would be x1 minus f of x1 by f prime of x1, which comes to 1.2609. A much better approximation would be x2 minus f of x2 by f prime of x2, which would be 1.2599. You can take it further, but I'm stopping there. Okay, 17th one. Fifth root of 6. So this would be x equal to fifth root of 6. Take it to the power of 5 on both the sides. We get x to the power of 5 equal to 6. So x to the power of 5 minus 6 equal to 0. This becomes the function, and f prime of x would be 5x to the power of 4. Now what will be x naught? 1 to the power of 5 is 1. 2 to the power of 5 is going to be 32, which is very, very big. So let's take it as 1.3. The better your initial guess, the better, the less the number of iterations you have to perform. And sometimes it may actually fail if the variation is too high. Okay, so let's see. X1 is equal to x naught minus f of x naught by f prime of x naught. This gives us 1.46015. X2 is equal to x1 minus f of x1 by f prime of x1, which gives us 1.43211. X3 is equal to x2 minus f of x2 by f prime of x2, which gives us 1.43097. So this is our fifth root of 6. Okay, now 18th one. Let's say f of x is equal to x square plus 2x natural log of x. We have to figure out the roots. Okay, what will be our initial guess? Now this would be a little bit tricky. Now here uh, we have to guess when will this be 0. Now if x value is positive, then this whole thing will be positive, so it will never be 0. There has to be some cancellation kind of thing. So it has to be negative, so that squaring will make it positive and this will be negative. Does that make sense? Now so this can never be negative because the square will make it positive. So this has to be negative. If this has to be negative, then x has to be between 0 and 1, not 0 included. 0 is not included. So it has to be 0 to 1 and 1 not included. So here x has to belong to 0, 1, where 0 and 1 are not included. So let's take it as 0.8 because the log of decimal points is going to be negative. So hopefully this will be the same as this. The only thing is this will be negative, so it will cancel out so that we can get a 0. Let's see. This is our guess based on some logic. Okay, so f prime of x is equal to 2x plus, now here we have to apply the chain rule. So 2x as it is, and natural log of x is 1 by x, plus 2x is 2 and natural log of x as it is. So x cancels and we end up with 2x plus 2 natural log of x plus 2. Yes, so this is our derivative. Okay, x1 will be x naught minus f of x naught by f prime of x naught. This will give us 0.71027. Let's take one more iteration. X2 is equal to x1 minus f of x1 by f prime of x1. This will give us 0.70351. Let's take one more. So x2 minus f of x2 by f prime of x2. This gives us 0.70347. 703. So if we round this off, it becomes 5. If we round this off also, it is 5. So up to 4 decimal places, we can stop. So this would be the value of x when f of x is equal to 0. So that is Newton's method. That's it. Bye.